Hi, welcome to Maths C Learning. Today I am going to explain limits and how can you learn easily limits. The first thing you have to ask question, what is a limit? What are some examples of limits? Before we go to what is limit, so you have to know the concept of limits. One of the most basic and fundamental ideas of calculus is limits. So limits allow us to look at what happened in a very small region around a point. First, what's the definition or the notation we use to write limit? This is the notation you can see. Limit f of x goes to some constant value equal some value, that is called limit. So when it comes to limits, you have to know left and the right limits. What is left and the right limits? So you know what is left and right. When it comes to one graph, we'll see how to point out left and right limits. For example, in this graph, if we want to find out the limit at 0 at this point, we have to look what happened from the left and the right. We have two notations. F of x, the limit x goes to a minus mean the value approaches from the left to this 0. The same as the right limit, you had to approach 0 from the right. We use the notation plus. The minus means the left, that's not the top minus. The top plus means right. If we want to find out what happened at 0, how can you modify this equation? You can see the limit for this graph, the function is called x cubed. X goes to 0 minus. The same as for the right side, we can write the limit x cubed, x goes to 0 plus. In the right side or the left side, you can see the y value is 0. Because of that, we can conclude what happened to the limit f of x without positive or negative 0, x goes to just 0, we can say the value of this also equal to 0. That's the easiest ways to understand the left and the right limit. Now, theorem. How to denote the limit theorem? If we want to say for the function f of x at c, the limit exists means you have to check both limit. What happened to the left and the right. If you get the same value, then only we can conclude the function also gets the same value L. If you get two different values, then you can say the limit does not exist. You can see in this example, one of them, the limit exists. For the second graph, you can see the limit does not exist. The reason for that, from the left side, you have a different value. And when approaches from the right to this point 15, you have a different value. That's the reason the limit does not exist. For this graph, there's no gap or anything. There's a continuous function. The limit exists all the points. Now here are some examples with the graph. At the same time, you can see the equation. Later I'll show you how to use equation without the graph and find out the limit. For now, easy to find out the limit when you see the graph, right? For the first one, what happened at 1 for this function, even though the point does not exist, but still we can say the limit exists. The reason, when you approaches from the left and the right, you can see the function value is equal to 2. Because of that, we can say the limit exists from the left. At the same time, limit exists to the right. the same value. From that we can conclude that what happened at limit for the first one exists and this value is 2. For the second graph, you see from the right side, even though you can see from the right side, we don't need to worry about this. From the right side mean you approaches from this side, also the limit value is equal to 2. The last one, we can see what happened at 1. From the left and the right is approaches to the same value, we can conclude that the limit value is equal to 2. That's the way you can find out the value for the right and the left. The limit always a number, right? So the limit can exist even though the function is not defined. You can see in those two examples, the function is not defined at 1, still the limit exists. Next, here are some other examples. What happens if you have a function f of x equal x squared? What happened at 2? Now we know how to make a graph of this. You can see the graph of that and see what happened at x is equal to 2. What happened approaches to 2 from the right and the left. You see the function value is equal to 4, right? You see this approaches to 4. So that's the value for the limit. Limit x squared, x approaches from the left and the right, the same value. We can conclude that limit at x squared at 2 also the same value 4. Next, here are some other examples. If you have some not continuous functions like this, how to identify limit at each point? You can see one by one. The first one at 4. What happened at 4? You can see is approaches from the left, we have a value, but from the right, we don't have any function. Because of that, we can conclude that left limit exists, but the right limit does not exist. Because of that, at 4, the function does not exist. The second point, what happened at 3? You can see the right limit and the left limits are equal. Then we can conclude what happened at 3, the limit value also equal to 2. The next one, what happened at 2? Even though the point does not exist, but still those approaches to 1. Because of that, limit exists. The last one, what happened at 1? From the right and the left, there are 2 different values. Because of that, limit does not exist. Here are some other examples. Without seeing the solution, you can try those questions and match with my solution. You can see one by one what happened at -2, 0, 2, 4, and 5, and 6, 8, 10, and 11. So you can check the solution for that. I hope you understand what is limit and how to calculate right and the left limit. Thank you for watching. Please see you in another lesson.